So when we left off on Friday, we were talking about basically the steps in order to perform a significance test. And so I have here listed for you your 4-step process, where we're going to state, plan, do, and then conclude. And so remember, when we state, we're stating the hypotheses that we want to use, our significance level, and defining any parameters. When we plan, we're going to choose the appropriate method and check our conditions. We're going to do our calculations, which involve the test statistic as well as a p-value. And then we're going to finally make our decision in the context of the problem. Okay? All of these things are really important. So once we know that our conditions are met, to test our hypothesis, we're going to compute our z statistic, which is following this formula here. Okay? P hat minus p sub 0, remembering that that is our null proportion, over the standard deviation of that null proportion, p sub 0 times 1 minus p sub 0 over n, all of it in a square root. Then once I have that z statistic, I'm going to look for the probability of finding a null hypothesis like the one I want by looking at the normal distribution. And so if my null hypothesis is that the p is greater than p sub 0, I'm looking for the probability of being greater than the z-score that I found. If my alternative is less than, then I'm looking for being less than the z that I found. And then the last, what you have over here on the end, is for the difference, the two-tailed tests, which we're not going to do today. We'll work on in our next class. Okay? So here is our first example related to significance testing. And we're going to work through this entire 4-step process on this example. So it reads, the potato chip producer of section 9.1 has just received a truckload of potatoes from its main supplier. Recall that if the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. Supervisor selects a random sample of 500 potatoes from the truck, and inspection reveals that 47 of the potatoes have blemishes. Carry out a significance test at the 5% significance level, and what should the producer conclude? So I'm just going to mark down a few important things here. More than 8%. Okay. So we start by writing down our hypotheses. And so my null hypothesis is going to state that the proportion is 8%, while my alternative is going to say that the proportion is greater than 8%. I'm going to include my significance level, which we said was a 0.05, and I'm going to define P as the proportion of potatoes with blemishes. Okay, so that takes care of stating. I stated my hypotheses, I stated my significance level, and I defined my parameter, which was the P. Once I've done that, I'm going to decide what test I'm using. In this case, we're using a one-sample Z test. And this is a test for proportions. All right, once that's done, my next step is to check my conditions. Okay, so we have the random condition, which has been met because a random sample of 500 potatoes was used. Then we need to check the 10% condition. So the size of my population should be greater than or equal to 10 times 500. So are all the potatoes greater than or equal to 5,000? In a truckload? Probably. Okay, if you're not sure, remember that you can proceed with caution. And then my last condition is the large counts condition. Okay, and remember we're checking n times p sub 0 greater than or equal to 10, and n times 1 minus p sub 0 greater than or equal to 10. So in this case, that would be n is 500 times 8%, and 500 times 92. All right, so this gives me 40, which is greater than or equal to 10, and 460, also greater than or equal to 10. All right, so my conditions are met. I can go ahead and continue with my test. And so first thing I'm going to do is I'm going to calculate my p hat, just to give myself a little bit of an easier time. So this is 47 out of 500. And this gives me 0.094. Okay, so my z statistic is going to be p hat minus p sub 0 over the square root p sub 0, 1 minus p sub 0, over n. I'm going to plug in 0.094 minus 0.08 over 0.08 times 0.92 over 500. And I'm going to do this calculation. All right, so this gives me a z-score of 1.15. Now we're talking about an alternative that says the probability is greater than 0.08. So what I'm looking for now is the probability that C is greater than 1.15. Okay, and now at this point I can use my table, the normal table, or I can use my calculator, the normal CDF, and plug all of that in. Okay, and if there are questions on this, we can go over this the next time I see you. I'm hoping that you remember how to do this though. So I went back and used the table. I looked at the z-score of 1.15 and found the probability of that from my table. And then because the table always goes with a value that's lower than that, I'm going to subtract from 1. So 1 minus 0.8749 is 0.1251. Now, if I were to use the normal CDF in my calculator, because this is a z-score, I would use this z-score as the lower bound, make sure my upper bound is a really large number, 99999. Leave the mean at 0 and the standard deviation at 1 because this is already a standardized score. Okay? So this value that I just calculated here, this is my p-value. Remember that my job really is to compare my p-value to alpha. So the question is this p-value less than alpha? So is 0.1251 less than 0.05? And of course the answer to that is no. So that tells me that I'm going to fail to reject the null hypothesis. So my conclusion should really be saying that I don't have enough evidence to support my alternative. So let me move this stuff up a little. Oops. Okay, so we'll say we do not have sufficient evidence change this a little bit. Do not have sufficient evidence that the proportion of potatoes with blemishes is more than 8%. So I'm going to change my wording up a little bit. So I'm going to say we do not have sufficient evidence to conclude. I'll make it a little bit more specific here. So I'm going to say the proportion of potatoes in the truckload with blemishes is more than 8%. And so the question said, what should the producer do? So this truckload of potatoes will be used. Okay, I think this looks a little bit better than what I had written earlier. All right, so here's the second question. And this question says, the drug manufacturer claims that less than 10% of patients who take its new drug for treating Alzheimer's will experience nausea. To test the claim, researchers conduct an experiment. They give the new drug to a random sample of 300 out of 5,000 Alzheimer's patients whose families have given informed consent for the patients to participate in the study. In all, 25 of the subjects experienced nausea. Use this data to perform a significance test of the drug manufacturer's claim at the alpha equals 0.05 significance level. All right, so I'm going to start with my null hypothesis. My null hypothesis is a statement of no difference, so the proportion is 10%. My alternative is going to say that the proportion is less than 10%. We're looking to use a significance level of 0.05, and P is the proportion of Alzheimer's patients who experience nausea with the new medicine. Okay. Now, again, we're working on a one sample z-test for a proportion. And so I'm going to check my conditions. I need a random sample, which we were given or told about. I need to check the 10% condition, and it said the random sample was 300 out of the 5,000 Alzheimer's patients. So 5,000 is definitely greater than or equal to 3,000, so we're good with that. And then finally, we'll check our large counts. And we're going to check n times p sub 0 greater than or equal to 10. And with the 1 minus p sub 0. All right, so this is my sample size of 300 times 0.10, which is 30 greater than or equal to 10, good. And this is 300 times 0.90, so that's 270, which of course is greater than or equal to 10. All right, so now I can go ahead and start working on my test stuff. So for my test statistic, before I do that, I'm going to calculate my p-hat. So p-hat was, let's see, 25 of the 300. So we've got 25 out of 300. So that gives me 0.083. My z statistic should then be 0.083 minus 0.10 over 0.10 times 0.90 over 300. So I'm going to calculate this. And that gave me negative 0.98. So now I'm looking for the probability that C is less than negative 0.98. So again, I can use my table, I can use my normal CDF. So this gives me 0.1635. Remember, I'm trying to compare my p-value against alpha. So in this case, 0.1635 is definitely not less than or equal to 0.05. So we're going to say we fail to reject our null hypothesis. So we can say we do not have convincing evidence that the proportion of Alzheimer's patients who experience nausea on the new drug is less than 10%. All right, and we'll go over this and a couple other examples the next time I see you, and then we'll talk about two-tailed tests.